Welcome back. We are starting elasticity, and this video we are going to give an introduction to elasticity. Then later on in our successive videos, we will be doing calculations involving elasticity. So to start with, let's define elasticity. Elasticity is defined as the ability of an object to regain its original size and shape after the removal of applied force. So an object with this property is said to behave elastically. When we talk about elasticity, here the object that is under consideration must have the ability to regain its size and shape after the removal of an applied force. So if the force stretches the object, thereby increasing its length, that force is called tension. But if the force compresses the object, thereby reducing its length, that force is a compressional force. It doesn't matter whether the force is tension or is compressional. What is important is after the removal of that applied force, the object must regain its original size and shape for it to be considered an elastic body. An object can initially behave as an elastic object, but if the force is excessive, the object may not regain its original size or shape. When that happens, the object is said to undergo a plastic deformation. Therefore, we need to know the differences between an elastic object and a plastic object. So the concept of deformation is what I need to define first. Whenever we talk about deformation, is the change in shape and size of an object. When a force is applied to an object. This is what we call deformation. So if you take an object and then you apply a force on that object, thereby changing its shape and size, that object is said to undergo deformation. So to consider an object to be elastic, after the deformation, it is supposed to regain its original size. But if the object undergoes deformation but could not regain its original size and shape, then it is referred to as a plastic object. So for the concept of elasticity, the object must regain its size and shape after the force is removed. All right. So let's say in front of us, this diagram that we are considering, we have an elastic object that is not yet subjected to any force. So the original length of the object is indicated as L0. That means the original length, otherwise called the natural length. Okay? L0 is the natural length, or some will call it the original length. Some will call it the unstretched length. That is, the elastic object has not yet been subjected to any force, so no force is applied to it. If we apply a force to this elastic object and then it stretches it, thereby making it to have a longer length, the final length it has, which we call Ln, or the new length, can be indicated with the symbol Ln. Okay, so Ln is called the new length. It can also be called the final length. It can also be called the stretch length. It can also be called the length attained. If we want to know the differences between the natural length and the new length, that difference is called the change in length, and it is very important in the concept of elasticity. So it means from this point to this point is called the change in length, delta L, which is also known as the extension, if at all the object has been stretched, or it can be called the compression, if at all the object has been compressed, making it to have a final length that is smaller than its original length. Okay, so if we want to find the change in length, otherwise called the delta L, is equal to the new length minus the original length. So this delta L is also called extension. Okay, delta L is called extension, and we can also represent with the symbol E. So we can say E, the extension, is the difference between the new length and the original length. So you have to understand this. All right. Now, regarding the concept of elasticity, a very important law called the Hooke's law should be discussed. And the Hooke's law states that provided that the elastic limit is not exceeded, the applied force is directly proportional to the extension. So remember, we said that this extension is the change in length. So Hooke's law explains that if you apply a force on an elastic object, it is going to cause extension. Okay? So the more force you apply, the more the object is going to extend, provided that the elastic limit is not exceeded. So to express that mathematically, Hooke's law states that the force is directly proportional to the extension. So that can be F is directly proportional to E. If we want to remove the proportionality sign in mathematics, we bring the equals to sign and replace it with a constant. Therefore, F is equal to KE. This letter K is known as the elastic constant. Okay? K is the elastic constant. Some will call it the spring constant, or some will call it elastic stiffness. There are different names it can be called. So F is KE. Remember that. To find K, we can divide both sides by E. So in that case, K is equal to F divided by E. So the spring constant or the force constant is obtained by dividing the given force by the extension. Now we can establish the SI unit of the spring constant, also known as the elastic constant. So K is equal to F over E. We know that force is measured in newtons divided by the extension, which is change in length and is measured in meters. So in that case, the SI unit will be newtons per meter, or you can express it as Nm to the power -1. That is the SI unit of elastic constant. It is measured in newtons per meter. We can now go ahead to determine the dimension of the spring constant. Again, using K is equal to F over E, force is measured as the product of mass and acceleration. So this will now be divided by the extension. K is equal to mass is measured in kilograms multiplied by acceleration is measured in meters per second squared divided by extension, which is change in length, is going to be measured in meters. So with this, we can substitute the dimensional unit. We know that kilogram represent mass, meters represent length, and seconds represent time. So for kilograms, it's going to be M multiplied by, for the meters per second squared will be L per T squared divided by, for the meters it will be L. K is equal to M. This L per T squared can also be represented as LT to the power -2, all divided by L. So K is equal to, the length will cancel length, so we're going to have MT to the power -2. This is the dimension of the spring constant or elastic constant. It is MT to the power -2. So because we do not have length here, if at all we want to still indicate it, alternatively we can say K is equal to M to the power 1, L to the power 0, T to the power -2. Dimensionally, both these units are the same, MT to the -2 or M to the power 1, L to the power 0, T to the power -2. To summarize, we've said that from Hooke's law, F is equal to KE, that is the applied force is equal to the spring constant multiplied by the extension which is also known as the change in length. We have also established the SI unit of the spring constant is newtons per meter, and we have also stated that the dimension of the spring constant is mt to the power -2. And also we have stated that the change in length is equal to the new length minus the original length, which can also be E is equal to the new length minus the original length. See you in the next lesson for the continuation of the introduction to elasticity. Thank you very much for your time. Please subscribe, like, and share the video.